Okay, let's start then. Good evening, everyone. Welcome to, what's that? Oh, sorry, I've got to be louder. Welcome to the Astronomical Society of Edinburgh. It's great to see so many of you here. Lots of faces I don't recognize. So really good. If you want to chat to someone afterwards about the society, can I get our council members to stand up so people know who they are, please? And then you want to chat to someone who knows about what's going on, please feel free to do that, or keep quiet or whatever. There's tea and coffee afterwards as well, so help yourself. This is what we've got happening tonight. A few introductory remarks from me, a few news items, what talks we've got coming up over the next few months. And then the main event of the evening is the Pluto Story from Professor Ian Robson. Sadly, he's not here. The rail strike tomorrow has forced him to stay down in Lancashire. He is online, however, so we'll be having it broadcast over Zoom. So it's not the same as having him here, but it still be a good talk, I'm sure. And we'll be able to ask questions from him as well. And then at the end, I'll be going through what's in our night sky in November. Lots of ways of staying in touch with us. So if you want to know what we're doing, what events are coming up, what meetings are coming up, our website has everything you need, Facebook and Twitter, and you'll be able to see lots of our past talks on our YouTube channel. And we've had quite a lot over the last few years. During lockdown, we did 2 talks a week, and we had speakers from all over the world. So there's a lot of good content on there. And we have 2 new members, Norman and Adam. I don't know if either of them are here today. No, but let's welcome them as normal. And our membership is growing very healthily, 180 now. A little reminder from our current members: if you joined before the 1st of April this year, then your renewals are due on the 1st of October. It's my fault. I didn't remind you that they were due on the 1st of October, but they are. And there's an easy way of doing it with a bank transfer or PayPal on a membership page. Or Alan is here somewhere. You can give him a check. And is he here? No, no, not. Not tonight then. Just a little rundown. We had a very successful partial solar eclipse event. We did a live stream from the historic Cook telescope on Carlton Hill. That's the first time we've had it back working since about 2008. So that was great to get that going again. We also had our solar scopes up there as well, and lots of visitors, loads of media interest. I need a press officer. I've had so many requests for newspaper articles and TV appearances and so on, which is not my thing. But some pictures of it going on up on Carlton Hill. That's a montage of the event from Will Joy. Beautiful place on Carlton Hill at the Collective Gallery. Collective, not the Collective Gallery. And someone put a big monument in the way of the eclipse and it eclipsed the eclipse at one point. We couldn't get it to move. Big thank you to Jim Anderson for getting the Cook in working order again. It's really good. And the old telescope, which was given to the city in 1896 by William McEwen, the brewer, is still working as perfectly as ever. So that was really good. Okay, meetings coming up soon. For members only, we have our imaging and observing group. That's online next Wednesday. Our next talk will be an online only one on the 18th of November. So if you're a member of the society, you can access our talks on Zoom. For everyone else, it's free to watch live on our YouTube channel as well. That one will be about extrasolar planets and what makes them habitable, from Patrick Barth of St Andrews. Very interesting one on the 2nd of December from Dr. Indranil Banik of St Andrews again. New forms of gravity, or new ways of looking at gravity. It should be quite a challenging one, but very interesting. An online, that meeting will be here. So the first meeting of every month we have here at the Augustine United Church, and we'll also stream it live on YouTube as well if you can't make it. 16th of December, talk about cosmic dust. That will be online only. And on the 6th of January next year, Claiming Back the Sky from Ria Urban. Ria is a member of the society, also a space journalist. And that's about the problems of all these satellites in orbit destroying the night sky and the challenges of what debris might do up there. That's enough for me now. If we can hand over to Ian. Sorry you can't be here, Ian, but we're so delighted to have you here as well. Thank you.
Okay, we're just going to switch over at this end. If you want to start sharing, I'll switch the share over.
Just checking how's the sound at that end of the world.
Sounds fine.
Someone's got a de-share. Okay, it's better. Okay, well, I apologize for not being with you. I was really looking forward to it. This will be my third lecture to the Edinburgh Astronomical Society over the decades, third different venue as well. And I was looking forward to St. Augustine's and seeing old friends and maybe going out for a beer with Graham afterwards. So the dreaded rail strike, unfortunately, put a stop to that. Secondly, I think I'd like to really congratulate members of the Edinburgh Astronomical Society for supporting over the many years the open days at the Royal Observatory with the solar telescopes. That really is very, very helpful. And I was very impressed with your webcasting of the eclipse 2 weeks ago. And amazingly enough, it was wall-to-wall sunshine in Preston. It's not that very often. Okay, so tonight's talk. First of all, I have to confess, I'm not a planetary astronomer. My research interests are in active galactic nuclei, supermassive black holes, and quasars, things like that. However, this is a story that I really was just very impressed with in terms of it happened in my lifetime. I attended all the events. And it also demonstrates how science and science and astronomy politics actually works. So let's get going with the Pluto story. And it's not about the dog, although the dog does have a little bypass in this. Now, planets in the solar system, 5 naked eye planets, Mercury, Venus, Mars, Jupiter, Saturn. Then, of course, once we had the heliocentric cosmology, then, of course, we realized that the Earth was a planet. So we had 6 planets going around the sun, and that was our knowledge of the solar system. Then in 1781, telescopes came on the scene, and William Herschel discovered Uranus. And then after people studied the orbit of Uranus, and this is really quite an achievement, they figured out that Uranus wasn't following just a direct orbit going around the sun. There was being perturbed by another, well, presumably planet farther out. And so we had this quest for another planet. And then calculations by Leverrier, a French mathematician, brilliant guy, calculated the position of this new planet which would perturb the orbit. And Neptune was immediately discovered the next night, the night after the position had been revealed. Neptune was immediately discovered with a telescope. But there was still some debate about the orbit of both Uranus, but particularly Uranus. And so people still had the possibility of another planet, and it was called Planet X. So the search was continuing for Planet X altogether. And the key person in this quest was the head of the Lowell Observatory, Percival Lowell. And he searched for Planet X from 1906 until he died in 1915. And then there was a legal impasse where his wife, Constance, wanted to get hold of all the records, but the observatory patrons refused this. And so it took quite a long time before essentially the search for Pluto could continue. It didn't continue until 1929 by a young man called Clyde Tombaugh. And he was only 23 when he started off. But the key thing he used was a blink comparator. And I'll tell you a little bit about that in a moment. And lo and behold, in January and February 1930, within a year, he discovered Planet X, which wasn't called Pluto then, but it was just Planet X. And there's always a thought, was this just by chance? But never mind, it was discovered. So this is Clyde with his Newtonian, but that wasn't what he used. In fact, he used the main telescope of the Lowell Observatory. And this is the magic device, the blink comparator. And what you have is you have 2 images of the same bit of sky. And you can see my cursor now. And so one image is here and one image is there. And you look through an eyepiece here and you rapidly flick between both images. And the eye-brain combination is really, really good at finding out things that have changed from one image on the left to one image on the right. This is one of the discovery plates for Pluto. And this is where those who are on Zoom have an advantage because you can see things much, much easier. If you look at this little triangle of stars on the left here, you can see the arrow pointing towards a very faint star just up from this one here. And on the right, here we go, there's the same faint triangle of stars, but that star there is missing and it's moved across to here, which wasn't present on the original image. So this is the discovery between 6 nights, January 23rd and January 29th. So this was the discovery image and it was reconfirmed a number of times. And in fact, when people went through the records, Pluto had been seen before, but not recognized as such. So now the naming of Pluto. And it really wasn't because of the dog. It looks like there wasn't any clear link that people have managed to find in the history of records between Disney's naming of the dog Pluto. I think, as far as I can gather, it's just that the researchers who were looking for the dog's name thought Pluto sounded damn sight better than Rover. So the Lowell Observatory had the honor of naming the new planet, and it had over 1,100 suggestions altogether, including Constance from Percival Lowell's wife, but that didn't even make the shortlist. Came down to 3 names when the staff voted on the three names, which was Minerva, Cronus, and Pluto. And amazingly, Pluto had been proposed by an 11-year-old schoolgirl called Venetia Burney from Oxford. And although she didn't actually propose it herself, she told her grandfather, who told the head of department, who then passed it on to Lowell, and that's what happened. And Pluto, god of the underworld, unanimous choice. And it may also have been the case that PL for Pluto sort of sounded like Percival Lowell, so that gets a little kick in there. And so that was the name, Pluto stuck. And interestingly enough, that then followed the convention of when new elements were discovered. We had uranium after Uranus, Neptunium after Neptune, then we have plutonium after Pluto. So this is a nice link between astronomy and physics in that sense. Okay, so now we've got the name. What do we know about the object? What do we know about Pluto? Well, the key parameters of a planet: size, mass, its orbit. Let's start with the mass. By 1931, the effect on the orbit of Neptune and Uranus, particularly Uranus, was around an Earth mass. So that was the assumption. Pluto was about as big or as heavy as the Earth was. In 1948, Gerard Kuiper, by looking at it sort of at the diameter, it wasn't a direct measurement, you certainly can't see that, but he sort of figured out actually it was smaller than that. It was only about 10% of the Earth's mass. So it's getting smaller, or it's very, very dense. In 1976, Dale Cruikshank and his group, they measured the albedo, the reflectivity of the surface of the planet, and found it was really composed of methane ice, which is a very high reflectivity. So it's very, very bright for its size, which means actually its mass is only much, much smaller. And they calculated only 1% out of the Earth. So all the time, Pluto is getting lighter and lighter. It's just shrinking. In 1978, discovery that Pluto had a moon called Charon. Looking at the orbital situation then gave 0.02% the mass of the Earth. So all the time, Pluto just shrinking. And no matter how you look at it, it's very, very light. And so that cast immediate doubts about, was this planet X or what was going wrong? So this is just a nice little graph which shows you on the y-axis going up Pluto's estimated mass in Earth masses, the logarithmic scale, and the year by which they were predicted. And originally it was like 10 Earth masses. And then by the time it got down to the 1930s, in this sort of area here, which is when Pluto was discovered, it had got down to about an Earth mass. There's the 1 for the Earth mass. And its observational mass has been shrinking ever since. And if you keep on going, it should have vanished by now altogether. And in fact, with better calculations of the orbits of Uranus and Neptune, because you have a longer time base and more accurate measurements, the reason for having Pluto essentially goes away. And once you had the Voyager probes passing by the outer solar system, calculating the orbits very, very precisely, the reason for having a Pluto to do any perturbations certainly vanished in terms of that. Okay, so what about Pluto's size? How big is it? Well, it's actually not very big at all. It's very difficult to determine. It's too small to measure directly until very recently with the New Horizons probe. You can make estimates, but you've got to have three parameters of albedo or reflectivity of the atmosphere. You've got to guess the density if you know the mass. So it's full of free parameters on this. The best estimate we have now is 2,374 kilometers from the New Horizons mission, which we'll talk about towards the end, a direct measurement. And those of you who are in the solar system and in the know, this is a very, very small number compared to the other planets. And how small is it? It's actually very small. Here we have the Earth, and here we have our moon, and here we have Pluto. So Pluto is significantly smaller than the moon. So it's a puny object altogether. And here we have the Galilean satellites and Triton, essentially from Neptune. And there we have Pluto. So Pluto really is small. So we have in terms of Saturn, Jupiter, and Neptune, it's got tiny moons, and for the Earth as well. Okay, so what about the orbit? This is the third parameter we might want to look at. Well, the semi-major axis is about 40 astronomical units. So it's 40 times farther away than the Earth, which gives an orbital period of around 250 years. Next two numbers are really interesting. The eccentricity is 0.25, which means it's quite elliptical. All the other planets in the solar system that we know have very low eccentricities. Essentially, they almost go around the sun in a circle. The inclination to the plane of the solar system, the plane in which all the planets sit, for Pluto, it's 17 degrees. For all the other planets, it's within 2 degrees. So this makes Pluto definitely look different. And this is just an example in terms of what it looks like. You can see Earth, Mars, Jupiter, Mercury, Saturn, Uranus, Neptune. They really are very circular and it's very, very flat, though it's not easy to see from this diagram. But Pluto is definitely very different. It's eccentric and it's highly inclined. So automatically, Pluto is different from the rest. Now, I just want to put that bit in, sow the seed of that information in everyone's head already. So he asked the question, okay, so Pluto is different to the rest of the planets. Is it similar to anything else? I mean, that's a scientific question you would ask. And the answer is, yes, it is. And it's similar to the Kuiper Edgeworth belt, discovered by Kuiper and Edgeworth in 43 and 51, respectively. And this is a belt, it's a regime of small bodies, thousands of them, reservoir perhaps for comets or centaurs, which are essentially bodies which float between the outer planets. Kuiper Belt object, KBO, I'm going to call it for the moment, was the first real discovery of this was in 1992 by Dave Jewett and Jane Liu from the University of Hawaii. This eventually was finally called Albion. And we know there's over 3,000 discovered. This is just the tip of the iceberg. With newer telescopes, this number will creep up to more than many tens of thousands, I'm sure. So what do we know about Kuiper Belt objects, KBOs? Well, astronomers love classifying them, classify everything. And these KBOs come in various forms, which is either cold, that means they're circular with non-inclined orbits looking like the other planets. They can be called hot KBOs, which are elliptical and inclined orbits, like Pluto. They can have resonance, which is orbital looking with Neptune, which also happens to be the case with Pluto. And they can be scattered by approaching too close to Neptune, means scattered into a totally different orbit entirely. Now, another name for these things is trans-Neptunian objects. So I will tend to use KBOs and TNOs alternatively as we walk through, but they're essentially all the same thing. One is just a modern version of the other name, that is. So this is an example of some of these TNOs or KBOs. And you see Pluto is the mauve one in here. And although it's different to the rest of the planets, it's actually quite reasonable compared with the rest of the KBOs which are labeled on here, apart from, look at this one, Eris. Hugely inclined, hugely elliptical. And this one called Sedna, which almost has an open hyperbolic orbit, almost. So it is quite amazing in terms of that. And here we have examples, artist impressions of Kuiper Belt objects. And you'll notice there are many Hawaiian names on this. And that's because much of the observation was done from the University of Hawaii in terms of the discovery. And we'll talk about three of those as we work our way through this. It'll be Eris, Pluto, and Sedna. These will feature in terms of this particular talk. So, what's the impact in terms of Pluto, in terms of its history and things like that? Well, the discovery in 1978 of a big moon, Charon, that caused an interesting stir because it promptly made the Pluto-Charon system different to anything else in the solar system. It turns out for all the other planets which have their moons, their satellites going around them, the center of gravity or the center of mass of the whole system always lies inside the body of the planet. This wasn't the situation for Charon. Charon is so big and so massive compared with Pluto. The center of gravity lies between Pluto and Charon. So both Pluto and Charon orbit around a single center of gravity. And that makes it unique in the solar system altogether. It's in many respects, it's a double object like a double star or a double planet, but it certainly makes it different from everything else. And by the mid-1990s, the planetary status of Pluto was being questioned by a number of proponents, particularly Dave Jewett. And when I was director of the Hawaii Observatory in Big Island, Dave Jewett came across and gave us a seminar. And it was very, very convincing that actually, from many, many stats, you would not classify Pluto as a planet. You would call it a KBO. And so I was sold on that, but it wasn't my research area. So I didn't give a toss to it, but I just thought it was interesting. However, things move forward in astronomy, and the International Astronomical Union, which we'll get to a little bit later, was suggested should reclassify Pluto from being a planet to something different like a KBO. And this came up to the Manchester International Astronomical Union meeting in 2000. And the IAU promptly said, no, we're not going to touch that with a barge pole, go away. And in 2000 also, the story was changing in America. The Rose Center, the American Museum of Natural History in New York, the Hayden Planetarium, it had a refurbishment. And when they put they hung the planets up in the planetarium of the museum, they omitted Pluto as a planet. And this was done specifically by Neil deGrasse Tyson, who many of you may have heard essentially doing American broadcasting, and is very famous in terms of an outreach broadcaster and the director of the Hayden Planetarium. And he then got lots and lots of hate mail saying, you can't demote Pluto. And so that gives you a hint about what might be coming in the future. Then things took a real interesting turn. In 2003, discovery of a Kuiper Belt object, or a TNO, called Eris. And at the time, it was thought to be bigger than Pluto. And so if Pluto is a planet, then Eris is a planet. It was discovered by Mike Brown. And so essentially it was just Mike Brown's 10th planet. Mike Brown, a famous planetary astronomer from Caltech. And then also in 2003, Sedna was discovered, which also was big. So was this Mike Brown's 11th? And the big question was, well, how many more planets are there going to be in the solar system? This is the only effectively significant image there is of Pluto and Charon. It's by the HST using the faint object camera in 1994. And the center of gravity is somewhere around out here. So they orbit as a dumbbell around a point about there. So that makes it very, very different. So now let's move on to the International Astronomical Union, the political arm of the IAU, or the scientific arm, I should say, really. It was founded in 1919. It's the world's largest professional body for astronomers. We have around 10,000, depending on how you count them, 10,000 members. And it has a great mission to promote and safeguard the science of astronomy in all its aspects through international cooperation. Excellent. Now, the IAU is the international recognized authority for assigning designations to celestial bodies and any surface features. So when you see modern ideas of what things are named by, they have to be recognized by and approved by the IAU, and they have a naming authority in terms of that. Now, what they do for the average astronomer, what the IAU does is hold a general assembly every 3 years. One of the largest, most diverse astronomical meetings, and this tours the world, but happens every 3 years. And for most professional astronomers, this is their only link and interaction with the IAU. So what's the IAU in terms of Pluto? I mean, clearly there's a dilemma for this, because it's already come up in 2000. 2003, they managed to pass a bug, but by 2003, they'd realized that they were going to have to do something. And so they agreed that Pluto would be a focus of the 2006 two-week General Assembly meeting in Prague. And so this was a lot of work going on beforehand, and they did work very hard, the executive committee. I should say the IAU runs with a whole pile of committees, and the top committee is the executive committee, who is sort of the wise men and women of the field. So they agreed in 2003 and 4 to set up a planet definition committee. They're going to define what a planet was. And so you tend to think, well, how hard can that be? And the answer is a lot harder than I had already thought. But things immediately got into trouble because the IAU already had what was called a Division 3. It had lots of divisions. Division 3 was planetary system science, and they had active galaxies, cosmology, history of astronomy. So lots of divisions. But Division 3, planetary sciences, they definitely wanted to have their say because they were the experts in what was going on. So it was starting to get difficult already. And so the Planetary Definition Committee had the following charge. This is what they had to do. And I'll go through these in detail and read them all out because they are actually important. I mean, words matter, and particularly when you're trying to define something. So 1, discussing the broader social implications of any new definition of a planet and recommending a course of action that balances the scientific facts with the need for social acceptance of any change. There's an overarching sentence. 2, addressing the status of Pluto and of the newly discovered TNOs in the light of recommendation 1, considering whether the current naming procedures for planets and minor planets have exacerbated the problem of defining a planet, and recommending whether revisions are needed, and finally, attempting to frame those recommendations as a resolution or resolutions that could be put before the Prague General Assembly in August 2006 for possible adoption. So this is a wide-ranging remit of go away, look at planets, and come back and tell us what you think. And so that was actually quite an overarching thing to do. The president at the time, Ron Eakers, for the 2006 meeting, came up with a statement which said at the outset, from time to time, the IAU makes recommendations on issues concerning astronomical matters affecting other sciences or the public. Hence, the IAU recommendations rest on well-established scientific facts and have a broad consensus in the astronomical community, words which would come back to haunt him in 2006. But nevertheless, it was a very pertinent sentiment. So the Planet Definition Committee, actually, they spent no time at all in doing this. And they came up with an answer almost immediately. And they said, well, this is simple. It's a planet is a celestial body that A, has sufficient mass for its self-gravity to overcome rigid body forces, so that it assumes a hydrostatic equilibrium, brackets, nearly round shape. And B, is in orbit around a star, and is neither a star nor a satellite of a planet. So it's got to be big enough for its own gravity to pull it into a nearly spherical shape. And they said, that's it, done deal, walk on. However, the IAU realized that this was going to be potentially controversial, to say the least, and so it prepared beforehand. It never had a formal press officer, and so 6 months before the General Assembly in Prague, which was in August 2006, it appointed a press officer who had turned out to be a very good friend of mine, who had been my secretary of the Commission on Astronomy for the Public, which I was president of. So I knew the press officer very well, was a great guy. And the executive, these wise men and women, although I think at the time I might have been only wise men, the proposal from the executive for the GA was essentially, we'll have 12 planets with potentially more to come. In other words, it's an open feast here. We have 8 classical planets that dominate the system, which is everything out to Uranus. 4 planets in a new and growing category of Plutons, Pluto-like objects, which is Pluto and Charon as a double planet, Eris, and then Ceres, and I've no idea where Sedna went. And And Ceres, of course, people will recognize it's an asteroid living between Mars and Jupiter, and effectively thinking, well, why is that got in there? And the answer is because it's pretty big and it's round. It's not that big, but it's certainly round. And originally, when Ceres had been first discovered in the 1800s, I think 1801, I think, or something like that, it had been classed as a planet. And it was only in 1850 it was reclassified as an asteroid, once a whole pile of more asteroids had been discovered. So this was a bit odd, but nevertheless, the GA General Assembly was 2 weeks from August the 14th to the 25th. And there was an embargoed press release issued on the 15th, and I saw it on the night before, the 14th. And I just was a big shock, because there are times when you read a document and you know people are not going to vote for this. It's just going to grate, even though the 8 wise or the wise men from the executive committee had said this. And so when I read this and I said, it's not going to work, the press officer was horrified. I mean, absolutely horrified. And he was saying, but the General Assembly has to agree. This is what the executive committee have said. And I just said, forget this. There's no chance this is going to be agreed. You just knew it just wasn't going to be agreed by ordinary astronomers, like me. So this was the picture that we had. And it's a beautiful picture. And again, those of you who are on Zoom definitely get the good option here, because Ceres is this tiny 1 pixel dot, which I suspect those in the auditorium room can never see, because I can only just see it on the screen here. Then we have Pluto and Charon, and we have Eris at the end. And see, they really are tiny, these bodies, in terms of that. So the IAU and the press. Well, the IAU had worked very hard to get the press on board. They recognized the potential impact, the societal retribution it might cause, and they made a major effort to keep the press, shall we say, on side with information and lots of information. And they wanted to ensure there was a transparent and open process of scientific debate. This was a very, very important. There was lots of information on the web, Q&A links for the press and the public and astronomers to answer questions on this. So it was, the IAU did work very hard to try and do a good job. This is the press room. This is Owen Gingerich, who was chair of the Planetary Definition Group, who they thought they'd cracked it, but unfortunately they hadn't at all. So what happened at the IAU General Assembly? And this is where I was really pleased that I managed to go to Prague. As I say, I went to Prague to attend all the AGN and the supermassive black hole and quasar sessions. But in fact, I spent all my time attending planetary sessions because it was so interesting. The first plenary meeting where everyone gets together in this massive auditorium, that just showed this is going to be very, very contentious. There was already lots of debate from the floor, lots of people saying this isn't going to work. So I then ignored all my sessions and went to the first meeting of Division 3. And I went there really early and got a seat. But there was standing room only and people couldn't even get in the door of this meeting room. So Division 3, the planetary scientists, were going to have a go at Pluto. Well, first of all, they were very, very unhappy with Pluto and Charon being a double planet. Unique in the solar system, doesn't fit anything else. They weren't going to be happy with that. And then the major disagreement about the definition of a planet. And this is something which just bowled me over. I'd never heard anything like it before. Division 3, the exponents of the knowledge of the solar system, the people who'd worked on planetary dynamics all their lives, they were 80s and, well, they weren't 90s, but they were certainly they all seemed old to me. And I'm old enough, but they seemed pretty old to me, and they were all men. And they were absolutely adamant. They want a further point to be added. A planet must have cleared its orbit, which is something I never even heard of before and never had considered, but they were absolutely adamant. This is a solid criterion it must solve. So that was interesting. And once that was out, there was counter proposals mounted, mainly led by Alan Stern, who was the project scientist or the leader of the New Horizons mission, the mission to explore the outermost planet Pluto and beyond. And so he wasn't very happy it was going to be not the outermost planet. He got an email petition going in no time at all, but he only got 200 names. But actually, when we will see 200 is quite an important number later on. And then people say, well, hang on. clearing of orbit rules out Neptune, because Neptune actually hasn't cleared out its orbit. It's in resonance with Pluto. And so the planet dynamicists said, no, resonance is fine. That's okay. And then people said, well, what about Jupiter and the Trojan and asteroids? And I'll talk a little bit about that in a minute, but I'm not an expert, so I'm not going to say very much. And again, people said, no. That's resonance, and it's all about Lagrangian points, which starts to get very technical. This is the only really technical bit in the whole story, so don't worry about it. This is the diagram which has the sun at the center, and then we have, this could be the Earth or it could be Jupiter, and let's call it the Earth for the moment. And we have the Lagrangian point L1 and L2, L3, L4, and L5. And basically what these points are, or these zones are, they're not exactly points, but they're zones, that if you plunk a body in one of these zones, it will tend to stay there because the gravitational pulls of all the bodies in the system are equalized out one way or another, along with the velocity. And so L2 is a stable parameter. And you will note that L2 is where nearly all the modern observatories are sent from the Earth, like James Webb Space Telescope. That goes to L2 because you don't use much fuel. You've got to keep it moving around and around there. As long as you can see the sun to get your batteries and your solar arrays charged up, then effectively you don't have to do very much else. It will stay where it is. So it's a very helpful place. So these are Lagrange points. Now for Jupiter, then you also have Lagrange points, L4 and L5. And these are the Trojans essentially moving around. And what we have, these are the inner planets going around. And there's Jupiter. And what we have is Lucy, which will go to these objects, was launched in October 2021. It'll arrive in 2027. It does a few Earth assists to get out there. Then it will look at the leading edge ones, first of all. Then it will come back in, get a gravitational assist by the Earth whizzing past there. Then it will go back out again. And by 2033, it'll investigate one of these trailing ones to learn more about the solar system. So back to the IAU General Assembly. The next Division 3 session was on the 22nd. And this was very, very stormy. I mean, people weren't breaking out into fights, but they were being very uncivil towards each other. And because of the crowding in the earlier session, it was moved to the main auditorium where you normally have plenary meetings. So a lot of people there and lots of passionate speeches for and against. Resolutions were being proposed, changed in real time. The president was really having a very difficult job holding all this lot together. And it wasn't total chaos, but certainly it wasn't smooth. And in the end of the day, the president of the IAU, Ron Eakers, was definitely losing control of this. Not that it was his fault. It was just people were so passionate and just absolutely getting charged up about it. So the final plenary session on the 24th, which is the Friday, was when the vote had to happen. And it couldn't be postponed anymore. There were lots of comments and still confusion about the status of Charon. And it was a packed session. But unfortunately, I was back in Edinburgh. I'd had to leave on the 23rd because I had a major meeting in Edinburgh where I was director at the time. And so I was listening and watching. I was watching the webcast, which was done in real time. So that was excellent. But you couldn't really see what was going on because it was a fixed camera. But I had my colleague in the audience who was actually just phoned back, and he was telling me all the things like, "Oh, this vote is close. It's getting really close," and telling me what was going on. So I felt plugged in. Now, instead of the president doing it, Jocelyn Bell Burnell essentially ran this session, and she was absolutely brilliant at it. She took all the sting out of it, and she had a set of props. And I've forgotten what the cornflakes and the balloon was. We clearly have Pluto, and we have the umbrella of the planets in the system. But she was actually brilliant, essentially, in doing this, and calmed everything down for the vote. And so the final resolution, and I'll read all these out. I mean, it may be boring, but it is very important, these words, and they get changed. So we have the IAU therefore resolves the planets and other bodies in our solar system, except satellites, be defined into 3 distinct categories in the following way. A planet is a celestial body that A, is in orbit around the sun, B, has sufficient mass for its self-gravity to overcome rigid body forces, so that it assumes a hydrostatic equilibrium nearly round shape, which we've seen these before, and C, importantly, has cleared the neighborhood around its orbit. So division 3 got their way in the final resolution. Secondly, a dwarf planet. And here we have, what is a dwarf planet? Is a celestial body that A, is in orbit around the sun, B, has sufficient mass, etc., 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 is round, and C, has not cleared the neighborhood around its orbit, and D, is not a satellite. So all of a sudden we have a new definition of a new thing called a dwarf planet, which I always thought was just a real cop-out altogether. I'd just call them TNOs. All other objects except satellites orbiting the sun shall be referred to collectively as small solar system bodies. So that's what you're meant to use, but most people I talk to don't use those at all. So never mind. And then we have amendments. And because it's an astrosoc I'm talking to, I will go through the amendments. If I'm doing a sidebar, I miss this bit out. So 1, insert the word classical before the word planet. So we have a classical planet now, and then these dwarf planets. 2, the IAU further resolves. Pluto is a dwarf planet by the above definition and is recognized as a prototype of a new category of trans-Neptunian objects. So this is sort of getting back into sort of saying, okay, well, actually, it's really a trans-Neptunian object, but we're going to call it a dwarf planet. And 3, the following sentence is added. This category is to be called Plutonian objects. A mouthful altogether. So here we have the vote, and this is what it looks like. Actually, this is what it looked like on the TV video stream as well. So you had to vote by holding up a yellow piece of paper, which you were given as you entered, because only official IAU members were allowed to vote, as opposed to the freeloaders who had gone there were not official IAU members. And so the results. The main resolution was passed with an overwhelming majority from the audience show of hands, and this is how it normally works. The first amendment, which was add the word classical, 91 votes in favor, but an overwhelming show of hands against, so that fell. Second amendment, Pluto, a dwarf planet and a new category of TNOs, passed with 237 for and 157 against and 17 abstentions. And the interesting thing, the third amendment failed with 183 for versus 186 against Plutonian objects. Now, this is really interesting because I've attended a number of these IAU general sessions where people had to vote. And you can see when the tellers go around and vote, they do it about 3 times and you get 3 different numbers every single time. So as far as I'm concerned, 183 versus 186 is a null result. It's not distinguishable from each other, because I'm sure that wasn't right, but never mind, it didn't really matter. So what happened next? Well, not total mayhem, but general mayhem. Big negative reaction from the public. The public were, to a first approximation, totally, utterly opposed to this. Many reasons because of the emotional connection with Disney's Pluto, particularly in the USA. Also from the professional astronomers, their charge that this was non-democratic. Only 5% of the world astronomers voted at the Prague meeting, only 400 members. And there are 200 members against it on the email signature. And that's actually quite right. It was very non-democratic. And generally, there was lots of negativity from the US, calling it European partisan, old stuff, and particularly by the New Horizons team members. So it really caused a lot of negativity in general. On the other hand, there was a wide range of press coverage, and much of it was certainly high class, certainly for the science papers and the science journals. And we'll just have a look at a few of them. What is a planet? The debate continues in terms of that. Nature, round objects. That's the headline, but there's a bigger article later on to come. New Scientist, down but not out, with a nice little cartoon. Family of planets and Pluto being ejected, carrying Charon as well. And the decision to relegate Pluto from planet to dwarf planet was a wrench for astronomers, but there's no need for tearful farewell. Science moves on, as they say. Nature, a major article, Pluto, the backlash begins. So a lot of publicity on this. And then essentially Science, which had the diagram I've already seen before, and of cosmic proportions, the decide Pluto isn't a real planet anymore, and why they did it. And then we have the sort of, not quite so serious ones, the opinion piece in the German Meinung. Pluto is kind planets, and that's what the astronomer thinks of that decision on there. And then essentially the other side of it. size doesn't matter, protest for Pluto, and then the scheme of ice ball thingy, not sure really, too small to matter, astronomers don't know. And then I like these. What is this? We are a what? A dwarf planet? Good grief. Welcome to Pluto. And then Pluto, 1930 to 2006. Revolve in peace. Pluto, proof that size matters. So I do like these. But there's a lot more in the press that you can see then. So what happened then? Well, I think astronomy and IAU, we learned many lessons in terms in general. Certainly the IAU did. The IAU now has e-voting for what they believe might be contentious issues. An example of that is at the last IAU in Vienna, the resolution of the Hubble law being recommended to be told the Hubble-Lemaitre law rather than just the Hubble law, after the famous Belgian cosmologist Lemaitre in terms of that. And of course, we have the New Horizons mission, which actually got there about the same time. So the launch was in January 2006. It passed Jupiter system in 2007 and got to the Pluto system in 2015. And then it started 2016 to 2025. It's going to investigate the KBOs. So you know, it didn't sort of go to the Pluto system and do lots of orbiting around it. It just hurtled through the Pluto system and flashed by altogether. And it took a variety of images. I'm not going to show you very many because I'm not a planetary astronomer. And these are on the web if you want to look at them. And Pluto is definitely a very interesting planet altogether. It's colored, it has rills, it has some craters, but not very many, but it has different areas and planes and things like that. And Charon is also an interesting object in its own right. So lots of new science coming out from the New Horizons mission as it hurtled past the Pluto system. And the New Horizons mission discovered that there were 4 more moons surrounding Pluto: Nix, Hydra, Styx, and Kerberos. Pluto has a very thin atmosphere, and this is my favorite photograph looking backwards, essentially sun reflecting around the atmosphere of Pluto, essentially backlit. And then moving out farther into the KBO system, it saw this peculiar dumbbell-shaped object, which is a KBO, which the modern version now of this means sky. The original name that NASA stuck onto was Ultima Thule, which had some connotations that the IAU didn't like at all. So this got renamed, as the IAU can do. But one thing it shows is that in the early solar system, these 2 objects clearly came together and stuck. And so this gives you proof that bodies can conglomerate together and then grow. And if you've got lots of time, you can grow big bodies by low collision forces, which then stick rather than smash each other apart. So that was a very interesting aspect in its own right. And this is a complicated diagram, which I will flash up and say, don't worry looking at too much. But it's saying that there's growing importance of TNOs or Kuiper Belt objects, which, and when I got these are the Kuiper Belt objects way out here. And in fact, by studying their orbits and their distribution and having supercomputers and lots of clever mathematics and lots more bodies in here, you can actually work out the origin of the planets in the early solar system and their evolution, the outward migration of the giant planets. It's very, very complex. It's very, very technical. And it's only been possible in the last few years, really, with supercomputers, more data, and actually really smart people. So it tells you now, you can study this and work out about the early solar system. Final speculation, almost the final slide. Is there a 9th planet? Mike Brown, the Caltech astronomer, solar system expert, he thinks so. And he's proposed there's a planet 6 times the size of the Earth, about 15 times farther out than Neptune, and Pluto is essentially the same as Neptune for a first approximation. And he proposed this in 2016, and it was based mainly on observations of Sedna. Most people, I have to say, believe this doesn't exist, and they think that his observations can be explained by resonances in the system. However, there is a possibility there might be a planet in the Oort cloud much, much further out, and there's continued speculation about this. Finally, interstellar visitors. How do I pronounce this? Oumuamua the Great Hawaiian name. This appeared suddenly in 2017. And this is the artist's impression of what it looked like, the flying pencil. And it hurtled through the solar system. It came in and zapped out again in no time at all. And it had a huge velocity. And this has to come from interstellar space. It's moving far too quickly to be retained by the sun. So it came in, hurtled past the sun, and hurtled back out again, and missed everything on the process, which is actually quite important. So then that makes us think about this. Should we really worry about interstellar wanderings? Well, interestingly enough, the Gaia mission, which has been mapping the stars in the sky for the last 8 years or something like that, I'm sure people in the audience know better than me. And it's got very precision measurements of where stars are, how they're moving in 3 dimensions, essentially. And it then can work out the dynamics of how things will propagate in the future and how things looked in the past. There's one dwarf star called Gliese 710, which lies essentially not too far away. And Gaia has worked out that the velocity and the orbital position of this and its movement across the sky means that in 1.3 million years from now, it will interact with the Oort cloud in the outer parts of our solar system. That makes it interesting, because that means the potential for sending comets into the inner solar system, which could mean an extinction level event for us. Who knows? So that's 1.3 million years. Watch this space. Thank you very much. The end.
Thank you very much. That was fascinating. You got time for some questions?
Sure have.
Yep. We'll ask questions in the hall first of all, then on Zoom, and then on YouTube. So if anyone's got a question, put your hand up and I'll bring you a microphone. Nope, I think you've covered. Oh, we've got one over here.
So when we used to hear on the sky at night new size measurements, the latest one was smaller than the one before, so it was sounding quite definite, like a measurement. What they were really just approximate guesses, were they? Not really facts at all.
Yes, that's a very interesting question. I mean, to a first approximation, that is the answer. You base your information or your knowledge or your projected knowledge on the best data you have available. And that data typically gets better as time evolves in the future. And quite often there is significant uncertainty, but the uncertainty is lost on press releases and members of the public and whatever. And you end up with a fact being something which actually was just a real probability rather than definite fact. So again, it's how science evolves and how better data always gives you better results in the end. So the answer is always going for better observational data to pin down theories and to get real facts.
Any other questions in the hall? Have you got any questions on Zoom?
Any more questions on Zoom?
Nope. Nothing on YouTube? No. Have there been any attempts to overturn the decision on Pluto over the last several years?
I would say not that I'm aware of. I mean, I was always a Pluto disbeliever, because I used to use the criterion: if you just discovered Pluto in 2003 and you'd never seen it before, would you in your right mind call it a planet, or would you just say it's a Kuiper Belt object? And I always thought, given all the information, you just called it a Kuiper Belt object. It was just by chance Pluto was discovered before anything else on that. So I've always been, ever since I heard about this in the 1993 from Dave Jewett's seminar, which was all new to me, but ever since he presented all that information in 2003, later on, then I think the answer was quite clear. It was Kuiper Belt object. Just for me, science moves on, things change. That's life.
Okay, we have two more questions here.
Hello, Ian. It's Alan Pickup here. Perhaps you remember,
Hello,
remember me. Yes, hi.
Absolutely.
I've got a question. Towards the end of your talk, you mentioned the possibility that there might be a planet in the Oort cloud. Given the definition of a planet, how could it be a planet if it was in the Oort cloud? Because it hasn't cleared up.
Well, you're right.
Its neighborhood.
My mistake. A Kuiper Belt object in the Oort cloud. Or actually, I mean, if it's big enough and it's cleared its orbit and it works out that it really is in the Oort cloud. I mean, in principle, you could still have an orbital system which cleared its resonance, but I think most people don't actually believe it anyway. But nevertheless, when you read the literature and you follow what's going on, it keeps popping its head up now and again. So it hasn't been put to bed. So I feel I have to make a comment about it on that basis. But I think it's more of hope than anything else, in the sense that if it's cleared its orbit and it's sitting way out, way out in the Oort cloud, then it could or could not be a planet. I mean, who knows? Good point.
Thanks. Good talk, by the way.
Thanks, Alan.
We have one more here, Kristen.
Hi, thanks for the talk. It was very interesting. One thing that came to my mind, since we had several objects of similar size as Pluto, was it kind of inevitable that Pluto would be the first to be discovered, or might it have been as well Sedna or any of the other objects that was first discovered and then thought to be another planet? What do you think?
That's a really good question. I think in many respects, it was just by chance. I mean, Pluto had been predicted to be sort of where it was based on perturbations, well, thought for perturbations of Uranus and Neptune. I mean, as it turned out, when people refined the orbits better, the reason for having a Pluto just went entirely. And I think there's a whole pile of chance involved in that. And good luck to Clyde Tombaugh by actually managing to find it. But I think it didn't have to be Pluto. I mean, Pluto is very bright. It has a high reflectivity, and it is one of the closer ones. But it's not beyond the possibility. But the difficulty of trying to do the searches in such a vast amount of sky, with telescope time being quite precious, actually is really quite difficult. So I think there's a bit of luck in it, but Pluto is bright because it's got high reflectivity, and it is one of the very closest. The other ones do tend to be a little bit farther away, but I think it would not surprise me if there are archived material where things like Sedna clearly appeared but wasn't recognized as such for quite a while. So I hope that answers your question.
Okay, if there are no more questions, then can we thank Ian again? Thank you.
Okay, thanks very much. Have a good rest of the evening and good meeting.
Say again, sorry.
Have a good rest of the evening and a good meeting.
Oh, thank you very much. Hope to see you here in person again next time.
Yeah, I hope I get up. I really do. Enjoy St. Days.
Thank you. Okay. The last thing for us tonight, just to be a quick run through what's in the sky in November, if you want to know what's above us. Not ready yet, sorry. I'm ready. Got the cue from the producer. Thank you. What's coming up? So the moon's obviously up there every month. These are the unless it's had its orbit cleared. We've got the first quarter coming. We've had the first quarter on the 1st of November. The full moon will be on the 8th of November this month. Apparently, this one's called the Beaver Moon. Don't know why that is. Last quarter on the 16th of November, and a new moon on the 23rd of November. For new members and for visitors, we have something called the AC24, which is an introductory observing list for beginners. So if you want to know what the best things in the night sky are, we have this on our website. It's 24 objects, named 24 because we were formed in 1924 for no other reason than that. And the first 4 objects in there are items on the moon. So it's actually a good way of getting to find your way around the moon. There are obvious features. Some of them you can see with the naked eye, some with binoculars and a small telescope. If you want to be doing more advanced stuff on the moon, there's something called the Lunar 100, and you'll find information about that on our website as well. So these are the 100 definitive features that you can find on the moon. And we have our own project in the society where members are trying to capture all those 100 features on the moon, and we're doing fairly well, about halfway through, but some of them are quite tricky to capture, but you find that on our website. If you want to image the moon, there are many ways of doing that, and we ran a training course, a few training courses online during lockdown. Basic imaging, just take a snap of the moon, either with a long focal length camera or through a telescope. Or you want to do really high definition advanced stuff, part 3 is there as well. So that's on our YouTube channel. And if you want to find out more about how to take photographs of the night sky in general, you'll find that there as well. Okay, the planets this month. If you've been out at night when it's been clear, look up high in the south in the evening, you'll see a really bright star, and that is Jupiter. It's still the dominant planet this month, and it will be for next month as well. Very bright, -2.7, and looking through a telescope, it's still the largest object to see. Saturn is heading westward now. It's quite low down. It's getting fainter. It's a bit lost in the murky atmosphere, so it's past its best for this year, but Jupiter is still worth looking at. The new star this month, not star, the most interesting one really is Mars, which is getting closer, getting brighter, getting larger, and that's you'll see that in the east in the evenings, and you can't mistake it. It's very definitely an orange star. And it's approaching opposition, which is opposite the sun for us on the 8th of December. This is what our orbit looks like. So there's the sun in the middle, and the Earth and Mars is directly opposite the sun, as seen from Earth, and that's happening on the 8th of December. It's actually going backwards at the moment, what we call retrograde motion. So from the start of this month, it's been heading westwards rather than its normal eastward journey through the sky. Obviously, it moves from east to west as the sky moves, but Mars normally would actually move eastwards against the background stars. But at the moment, because of where our orbit is in relation to Mars, it's going backwards. You can see that arrow. It's actually heading between the horns of the bull. So Mars to the left there, Aldebaran is the eye of the bull, and Mars is moving in that direction with Orion down below. One of our Meteor cameras captured this really nice meteor earlier on in the month. There's Orion underneath, and the meteor is just passing the bright star Betelgeuse, or Betelgeuse, depending on how you want to call it. To the right is the star Aldebaran, and at the top is Mars. Those are 3 red objects, which is quite interesting because Aldebaran and Betelgeuse are red stars as well as Mars. It's quite interesting. We had the Orionids meteor shower last month, and that normally peaks on October the 22nd, but we have a few meteor cameras, and we think there was a separate peak on the 24th. Was it a real peak? I don't know. Was it just it had better weather than on the night of the maximum? But it's quite interesting to capture these sorts of data now. There is a meteor shower this month, the Leonids, on the 17th of 18th November, but it's not due to be very good this year. The rates are predicted to be pretty low. Every 33 years, I think, you can occasionally get a really good meteor shower, in fact, a meteor storm, but we're not due for that for quite a while yet. Is it another 10 years? I can't remember. Right, so another 33 years after that, yes. It's 33, yeah. So maybe we'll get a meteor storm then from the Leonids. Carrying on about meteors, so I said a few of us have meteor cameras, and this is the The coverage of the cameras, I've been bashing on to members about this, so if you're a visitor, you haven't had this yet, but the rest of them have had enough of me talking about Meteor cameras. But our cameras can cover quite a lot of the UK now, north of Scotland, down into England, and we've caught quite a lot of really bright meteors and fireballs as well. And as part of the UK Meteor network, we can get hundreds of detections every night, and matched with other cameras, maybe down in England or the north of Scotland, we can actually calculate quite accurately where the meteor came from, including the orbit, which orbit it came from. Is it from the asteroid belt or from a comet itself? So it's really quite good, and it's all automated. Looking in the night sky now, so these charts are for about 9 o'clock in the middle of the month. It'll be similar all throughout the month. So on the right-hand side there, going westwards, the summer triangle that's been with us all summer, that's starting to head to the horizon now. It's no longer as prominent. Over in the east, the winter constellations are starting to rise. So we've got Taurus and Mars, as we've discussed already, and Orion down below. This is hot off the press from just today from Fran Goodman, one of her beautiful wide-angle shots of the Pleiades and Hyades and Mars as well. And that was from just today, wasn't it, Fran? Yeah, something like that. High up in the south, we have the square of Pegasus. It's not very bright, but it is quite definitely a square there. Not very many stars within that square, and underneath it is the bright planet Jupiter. You really can't miss that. I'm known for being a bore about globular clusters, so I put one in there. There's a nice globular cluster M15 in Hercules. I can't believe that's the only picture in our Flickr group, but it is, so it's mine, so I had to put it in. North of that, above that, in the constellation of Andromeda, we have the Andromeda Galaxy, which on a really dark night away from streetlights, you can see with the naked eye. So that's about the furthest you can see with the naked eye, 2.5 million light years away, or 2.5 million light years years into the past, if you want to be a Time Lord. And this is a beautiful image taken by Mike McGovern just last week, I think, of the Andromeda Galaxy. Looking north, about the same time, the plough is the usual marker, but it's below the pole star, so it's quite low down now, but you can still use it to find the way to the pole star. Over there, getting higher in the east, is the constellation of Origo with its bright star Capella, and there's quite a lot of interesting objects in there for those of us who like to image. High above is the less distinct constellation of CPhys, but for us imagers, it's got lots of interesting features in there. So there's something called the Wizard Nebula from Ian Smith, and that one's the Elephant Trunk Nebula from Pat Devine. These are taken either from on the edge of Edinburgh or in the centre of Edinburgh, so you can actually do astronomy within the city if you have the right kit, software, filters and so on, but that's something that's really come on dramatically over the last few years, the ability to do that. The north is actually not a very interesting area. A lot of the stars are around the pole. A lot of the constellations are really pretty bland. So that's where I'm going to focus, I think, because that's what I find quite interesting. So there's a constellation called Draco, or Draco, depending on how you pronounce it, the dragon, which is just there to the west of Ursa Minor. And it's a pretty innocuous constellation. None of the stars are particularly bright, but if you dig into it a little bit more, you can find some interesting things. So this star here, Alpha Draconis, or Thuban, is a very uninteresting looking star just below Ursa Minor, Little Bear. But it's actually quite important because it actually used to be a pole star. You can see Polaris at the top there, which is a pole star now, but from 3942 BC until 1793, it was actually the pole star. That's because of the precession of the Earth's pole. But it actually had quite a lot of importance for the Egyptians as they were building their pyramids. They built them so that you could always see Thuban through a gap in each of the pyramids. It was always facing that way. And it will be a pole star again in 21,000 AD if you're planning on waiting for that. And it means head of the serpent, which it isn't, because the head of the serpent is to the left there, that strange shape. And it isn't even the brightest star in Draco. It's one of the 8th brightest as well. But it is quite interesting. The TESS transiting exoplanet satellite has discovered that it is actually a binary star and does some amazing eclipses as well. It is one of the brightest known eclipsing binary stars, where the stars pass in front of each other. Because it's so bright and large, it's really useful for astronomers to be able to measure accurately the size masses of those stars. Still more in Draco. There is a nice planetary nebula, Cat's Eye Nebula. Don't know if you can see that on the screens, but there's quite a lot of structure around that star from Nigel Goodman. If you have a Chandra X-ray Observatory plus Hubble, then you can get a bit more detail. So you need to do a bit more work, Nigel, on that one, I think. But basically the result of something like our sun that runs out of fuel, becomes a red giant, throws off its layers and leaves behind a very dense white dwarf and produces some nice, beautiful tendrils coming out of the star. Down at the bottom here, there is actually a Messier object in Draco M102, and that's the Spindle galaxy, which Peter caught. There is a weirder galaxy, which I haven't seen anyone in the Society capture yet, called the Tadpole galaxy. That's a Hubble picture of it, but looking at amateur pictures, you can actually capture the Tadpole galaxy yourself. So putting that one out there as a challenge to our imagers to capture that one. No pressure. At the top there, we have a really nice open cluster, which is very close to the pole star. That's #1 in the Caldwell catalogue. That's from Nigel again. And one last thing in here. TESS, the transiting exoplanets space probe, whatever it is, as this year has found a new exoplanet go around a star in Draco called 1181b. Not very catchy. So that is a discovery this year, and they've been putting out requests to capture the transit. So I managed to capture that last night. It's a bit noisy, but you can actually see the transit of the planet because it's only really been observed when it was discovered, and they didn't know whether the transit time was correct. And my observation said it was 12 minutes late. So I don't know whether that'll turn out to be true or not, but it's a bit messy. Comets, there's nothing very much in the night sky at the moment. We do have one around. One of our members, Douglas Heggie's been monitoring it quite a lot over the last year or so. The catchy name C2020 V2 ZTF. It was ZTF because it was discovered by the Zwicky Transient Facility, which is a telescope in Palomar. And Douglas says it's now starting to form a tail, which you can just about see on that picture. You can see the path of the comet there. It is actually at this very night right at the edge of Ursa Major, in fact, right by one of the pointers, Dupé, and it will be heading higher up in the sky throughout the next few months. And this is the graph showing the brightness and the projected brightness. So it is getting brighter, but it's not going to be naked eye brightness. So unfortunately, I still don't have a good comet for you. Andrew managed to get a good comet last year, but I haven't managed to do that yet. Not really astronomy, space. I just thought I'd bring this up because a lot of us are interested in the space program, and the Artemis launch is going to happen, or is scheduled to happen on the 14th of November, about 5 o'clock in the morning if you want to get up. And that will be ascending the rocket around the moon, spending about a month out there and testing out all the new systems. So that should be very exciting if it does actually happen. And that's it. That's it from us tonight. I'll just put the program up of what's coming up. Hope you enjoyed it. I'd love to see you again. All our meetings are free. You're always welcome either here or online on YouTube. But feel free to stay around for some tea or coffee and chat to us, and hopefully we'll see you again. Thank you.